I bet you can do just great. All right, what are the coordinates of vector AB? Well, we know the coordinates of A and we know the coordinates of B. Now we're going to find the coordinates of the vector from A to B. So what did I hear? I heard something. 2, -6. 2, -6. I don't know. Let's check that out. We're going from 1, -2 to 3, 4. Would you agree that that's 2? -6? Shouldn't that be +6? I mean, it's counting, basically, you guys. Nothing hard about that. We're going from 1 to 3 and from -2 to 4. So the coordinates of that vector would be 2, 6. Everybody all right with that? All right, the next one. V plus 2u. By the way, what do we call it when we add two vectors together? We call it the resultant. Oh, Rose, when did you come in? I marked you absent. Have you been here the whole time?
Like 2 minutes, but now I'm just taking passes, so I was just going to tell you when you're done teaching.
Okay, so we call it the resultant. All right, what would V plus 2u be? Well, let's see. Let's start with V. Here's V. And now we want 2u. All right, what's 2u? What would 2u be?
You distribute the 2 to the 5 and the 1.
Yep, so it would be 10, 2. By the way, what do we call 2? Ooh, our vocabulary, don't let that slip away. It's called a scalar. All right, now we're going to add these together. What do we get when we add them together? 8. What? Easy peasy. All right, what's number 3 mean? The dot product, v dot u. So we're going to dot -2, 3 and 5, 1. What would the dot product here be? -10 plus 3. So the answer is -7. Remember, the dot product is a number. A number. One number. The dot product is always a number. All right, what does number 4 mean? The opposite of u. Well, if u is the vector 5, 1, what would the opposite be? No, 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 no. No, if u is the vector that travels 5, 1, then the opposite would be the vector that goes from here to here, which would be -5, -1. Opposite vectors are like if I walk to Hiddle and then he walks to me. Okay, those are opposite vectors. We're going exactly the same distance, but the direction is opposite. Instead of going north, we're going south. What does 5 mean? Well, it looks like absolute value, but it doesn't really mean absolute value. What does it mean? The magnitude. And magnitude is just another word for length. So you have the vector that travels -2, 3. If you want to draw a picture of it, you can. It would look like this. Left 2, up 3. Here's this vector. How long is that? Root 13. Remember, when we find the magnitude of a vector, you can, of course, draw a picture and do the Pythagorean theorem. If you happen to know the endpoints, the initial point and the terminal point, you can do the distance formula. Or you can just square, add them up, and take the square root every time. And then we've got this little boneless which you should be able to do. It won't be a bonus. All right, and we know that A is 1, -2, and C is 5, 1, and B is 3, 4, and we gotta find D. And we want these two to be equal to each other. This is 2AC. We need 2 ACs to equal BD. All right, any idea how we would even start this?
Find the magnitude.
Well, be careful. Is there any indication here that we're talking about magnitude?
Find the vectors.
Find the coordinates of the vector. Yeah. So what would A to C be? What are the coordinates of A to C?
4, 3.
A to C is 4, 3. Good. Now what would 2AC be? 2AC would be 8, 6. So we need this vector, BD, to have coordinates 8, 6. Everybody agree? So we know our starting point, and we have to have the coordinates 8, 6. So if we start at 3, 4, where are we going to end so that the vector travels that distance right there? 11, 10. Perfect. Everybody okay with that? All right. Turn the sheet over. We're going to get started on this in a minute. But first, let's look at your homework. You have some parametric work to do. We're not going to go through every one of these problems, but there may be a couple that you had a question about. And there are definitely a couple I want to talk about because they're important. So I'm just going to jump in on the back of your homework packet, number 12. This is kind of an important kind of problem, so let's look at it. Now, did you graph this on your calculator?
No, we didn't.
Okay. All right, let's take a moment and do that, just so you get a sense of what is going on here. And then we are going to, talk about how that equation, or that system of equations there, relates to an equation you are already familiar with. All right, so we're going to graph in parametric mode. So the first thing you need to do is go to mode. And you notice that one of your options is PAR. That stands for parametric. So go to mode. For me, it's the 4th line down. I'm going to click over. I'm going to click over and highlight parametric. Now, because of the directions on the sheet, let's set our calculator in radians, because the directions say 0 to 2 pi. That points around our circle. All right, everybody good? Now, press Y equals, and you will notice that now the calculator is asking you for 2 different equations, right? So let's put them in. So 2 cosine t, and don't be alarmed, the t is your x button. Only now it's a t button because you're in parametric mode. And then 3 sine t. Now, before you graph, some of you are already ahead of me, I'm sure. Go to your window, and let's make sure our window is set up right. Tell me about your window. What does it say? T-min? 0. T max, 2 pi. Why? Because that's what the directions said on the worksheet. Now, T step. This one's a little bit flexible. We're going to spend a little more time in the coming days talking about that. Just press 0.1 for now. For your X mins and maxes, let's just use -4 and 4. Now while you're doing that, -4 and 4 for X min, Y min, X max, Y max, -4 and 4. While you're doing that, let me try to explain it to you. Remember, cosine and sine will never be bigger than 1. So the very biggest X could be is 2, and the very biggest Y could be is 3. So I set it at 4 and -4 to make sure I have a little bit of extra room. All right, let's press graph and see what we get. Now, what shape did you get? Now it looks like a circle, but I want you to look at the scale a little bit. How far sideways does that thing go? How far up and down does it go? Okay, it's not a circle. Press zoom, and then go down to where it says zoom square. For me, it's number 5. I don't know what it is for you. And you will see the actual shape. Whose is that?
It's not mine.
If you open it, turn it off.
Who knows what this? Shake it down, pass it around.
Let's put it in the car. Oh, can you turn it off?
Talk to Siri and say what's
They're not going to find it.
If you just put it right stuff.
Okay, did you get an ellipse? Okay, it's a beautiful little ellipse. Now, here's the nice thing about what you just did. Is this a function? Kids, is that a function?
No.
No, it does not pass the vertical line test. Normally, your calculator is a function machine, and it only deals in functions. But when you switch to other modes, like parametric mode, it will allow you to graph things that aren't functions. Now, what do you think would have happened if that would have been a 3? It would have been a circle. Very good. What significance did that 2 and that 3 have in terms of the picture? 2 sideways, X, 2 sideways, and 3 up and down. So if you had had a 4 and a 5, then you would have gone 4 sideways and 5 up and down? Very good. Emma?
I only got half of the graph.
Check your window. Make sure that you are 0 to 2 pi. And then I'll look at it. All right, now, last year you studied ellipses. Remember graphing them? And you did not do it this way. Last year your equations looked different. So we want to get from this equation, or this set of equations, to the kind of equation that you studied last year. All right, you have an idea how to do that. It's actually quite easy. Do you have a thought on that? Dan, is your hand up?
Oh, I was stressing. Sorry about that.
All right, here's what I want you to do. I want you to divide this top equation by 2. And this one by 3. Now I want you to square both sides. So this would be x squared over 4 equals cosine squared. And y squared over 9 equals sine squared. you to add these together, up and down. So here's my equals. So what have I got over here? X squared over 4 plus y squared over 9 equals what? 1. That is 1. Does that equation look familiar?
Yes.
Remember last year, graphing ellipses? And they always were equal to 1. You had x squareds and y squareds. Remember that? That is the ellipse that you just graphed. Pretty cool. Pretty cool.
Alright, so that's the final answer.
Well, the directions were find the rectangular equation. That's the rectangular equation. Now, we did some other stuff here with the graphing and all that, but this was your objective. By rectangular equation, we mean x's and y's. No t's. Get rid of the t's.
If both numbers on the bottom were 4, would you multiply and then
Then it
equal
would be a
4?
circle. If that had been a 4, then you would have x squared plus y squared equals 4. Yeah,
Okay.
that would be a circle.
Thank you, man.
Thank you. Sorry.
Okay, that mystery's solved. All right, let's I don't want to get too bogged down in all of this, but let's look at maybe how about number 9? It's a little bit different kind of equation. There's no cosines and sines in it. And your job, look at the directions, your job is to eliminate the parameter and write the rectangular equation. So somehow we have to get rid of the t's. Now, when we had cosines and sines, we did the whole squaring thing, so we could add them together and get 1. What do you think we're going to do here? Our job is to get rid of the t. We don't have any t's left. This is number 9.
Would it be t equals x squared?
Okay, we could take this top equation and square both sides. And what good would that do me then?
You could substitute.
Now I can take that guy and plug him in right here. So my new equation is x squared minus 1. What shape is that? All right, let's graph and see if we get a parabola. In parametric mode, let's graph and see if we get that parabola. So you got to clear out your old equations. Now, tell me what happened. Did you only get half of it? Ah, I heard somebody say something that was profound. What was it?
It's the square root of t, you can't do any negative.
Exactly. Take a look at this right here. The square root of t, this is going to be a positive number. So what does that tell you about your x values? No matter what, your x values are going to be positive. And so when you sketched it, even though you may have anticipated, actually, like this one, even though you may have anticipated the whole thing, you can't get it because of the way the problem's set up in the beginning. Good work. All right, that's good. When you did your sketching on the rest of the worksheet, Were you plotting points? Okay, and now you have another option, so maybe now you go back and type a couple of them in on your calculator and see if what you got when you plotted the points is the same as what you get on your calculator. Now, I'm going to caution you, there are that's kind of an unfortunate word, but there are limitations set up for your X's and T's in these problems, and so be careful when you put it in your calculator. Make sure you're giving the calculator the same information. You know, T min, T max, as set up in the problem. All right, that's good. All right, let's look at this sheet that I gave you then. Where this is in-class review on the back of the quiz that we just did. Okay, on the back side of the quiz, we just took let's jump down to number 12 because that one looks familiar. Can you do problem number 12?
Yeah.
Tell me what you want to do with problem number 12.
Divide the 3 and the 4.
Step 1. Divide. So we're going to end up with x over 3 equals cosine and y over 4 equals sine. Square both sides, so we have x squared over 9 equals cosine squared, and y squared over 16 equals sine squared. Well, now, you don't just plug them into 1. Now you've got to do what? What do? Add them up and down. Here's the equals. So everything on the left would be x squared over 9 plus y squared over 16. And everything on the right would just be 1. And there's your equation.
Is Cartesian just another way of it?
Cartesian is the same as rectangular. It means x and y. Remember, this is called the Cartesian coordinate plane. So Cartesian, yes, x and y are rectangular. Cartesian and rectangular mean the same thing. Yes, Alexis?
Is the one coming from like the sin squared plus sine
Yep,
squared? Okay.
that's exactly where it comes in. Yep. All right. Well, let's just continue working from the bottom up. Number 11. We did this before I left last time. Now, I didn't plot these points. I don't have them oriented correctly. It doesn't matter. Just pop them up there. Your job is to find the measure of angle B. Now, there are lots of ways to do that. I'm going to suggest we use the dot product. But there are lots of other ways to do it. So who can impress me with your remembering the last thing I talked to you about over a week ago was how to find the measure of an angle using the dot product. You remember that? Anybody remember anything about that? Victoria. There are 2 definitions of the dot product. Very, very good. So the dot product is magnitude times cosine of angle between. So if we know this number, if we can find, this is just a number, like 6. If we can find this number and divide it by the two magnitudes, that will give us the cosine. That's exactly what you just said. So in order to do the whole problem, I need some vectors. I don't have any vectors. At this point, I have 3 ordered pairs. So let's build some vectors. If I want angle B, now think about it, angle B, which vectors should I be looking at if this is the angle that I want to build? BA and BC. So let's build BA and BC. All right. What are the coordinates of BA? B to A. -2, 6. And how about BC? -4, 5. Now, what Victoria said, the dot product. All right, let's find the dot product. How do we do that? Here are your 2 vectors. What's the dot product going to be? 8 plus 30. 38. Remember, the dot product is a number. One number. X times X, Y times Y. Now, what is the magnitude of that vector?
Root 40.
Root 40. Very good. This vector, that was BA, right, has a magnitude of root 40. Now, I don't know how Dan did that, but he could have done the distance formula. Personally, I would have squared and added them up, taken the square root. But somehow you got to get 40. All right, what's the magnitude of this vector?
Root 41.
Root 41. So 38 is root 40 times root 41 times the cosine of that angle.
So cosine of the angle is 38 divided by.
So the cosine of that angle is 38 divided by, what's 40 times 41?
A lot. 16.
Oh, I should be able to do this without it. Is that 1640?
1640. Yep.
And then I'll go to my calculator. And what?
The second cosine.
Yep. And what'd you come up with? Oh, we're in radians. You might want to change back to degrees. What'd you come up with? Ooh, I didn't get something .67. I got 20.22. Double check that. Type this back in. Make sure you're typing it in right. Now, kids, let's review those steps. All right, that's a GTQ, guaranteed test question. Let's review these steps. I gave you 3 points, make a triangle, find an angle. Step 1. Make the vectors. And the vectors you make are important. If you want angle B, it's gotta be BA, BC. All right, then what? Once you get the vectors made, then what?
Find the magnitude.
You need the magnitudes of the vectors and you need their dot product. The order you do that doesn't matter. You need this number and you need these numbers. And then you simply divide and second cosine. Okay? Now, look at the scenario that you have and look at question B. this angle, you know this side and this side. How are you going to find the area of that triangle? 1/2, side, side, side. So the area of the triangle will be 1/2 root 40, root 41, sine 20.22. Now, there are other ways to find the area for sure, but boy, if you got this, that's the quickest, fastest, easiest way to do it, right? Are we okay with that? Any question about that problem? All right, number 10. Tell me how you would do this. We have a line through -1, 5, and 2, 4. And you're going to write the parametric equations of it. This is number 10 we're working up. Robert?
Would you put it in y equals mx plus b form?
All right, let's talk. We can do that. We can do that. So what would you do first?
You find the slope.
And how would I do that?
4 minus 5 over 2 minus -1.
So -1/3.
Yeah.
All right.
And then you'd do y equals, so you'd plug in 4 for y and 2 for x. And then you just solve for b.
So I get y equals -1/3 x plus 14/3. All right, now what Robert has done, I mean, we're not done. We haven't done what we're supposed to do yet. We've taken 2 points, and what have we written? We've written the equation of a line. But what kind of equation is this? Slope-intercept form, Cartesian, rectangular, x's and y's, and what do the directions say? Okay, so somehow we got to get from this to a parametric form. You have an idea?
Would you solve for x and solve for y? Oh, would you substitute the x for t? Is that a possibility?
Oh, well, anything's possible, Robert. Now, whether it's legit or not, no.
Yeah.
Here's what I want you to think about for a second. I'm gonna just come over here and we're gonna wait on that for a second and do a little bit of background here. Now what I would like for you to, okay, are these parametric equations. And at this point they have nothing to do with this, okay? We're taking a break. Coming over here, we're gonna make a discovery. Hopefully. I would like you to eliminate the parameter. In other words, I want you to write, just like you did in your homework, I want you to write a rectangular equation for this. So, how do we do that again? You know how to do it. Get t by itself. So, it might be easier to do this one. So, what would t equal? 3 minus y, maybe? Can you do that okay? So x equals 1 plus 2 times 3 minus y. So x equals 1 plus 6 minus 2y. And x plus 2y equals 7. If I clean that up a little bit, how does that look? What is that the equation of? That's the standard form of a line. So this is a line, right? These are parametric equations that describe this line. You okay with that? Now I want to show you something that maybe you hadn't talked about before. What is the slope of this line? Negative 1/2. I'd like you to look right here. The slope of the line is negative 1/2. Y over x. What happens when you put those t's and you put this t over this t? What do you get? You get negative 1/2. The slope of the line shows up in the coefficients on the parameter because the parameter is telling you which way the line moves. And this is saying for every negative 1 step you take in the y direction, you take positive 2 steps in the x direction. Now, let's go back to this line we found. Would you agree that the point 1, 3 is a point on that line? That the point 1, 3 fits that equation, okay? When you write the parametric equations of a line, this represents a point on the line, and these give you the slope of the line. So when I look at parametric equations, I can tell you right away that a point on the line is 2, 5, and the slope of the line is 6 over negative 3. Remember, slope is always y over x. So let's come back to our problem, which was this. And I love all the work that we did, especially this. We need the slope. And we're going to write these parametric equations. Now, what goes here? A point on a line. Oh, does it matter which one I use? No. I like positives. I'll use 2 and 4. You could use negative 1 and 5. Are there other points you could use? Yeah, there's about 1 million points on that line, right? Actually more than 1 million. Any one of them would work. Now, what goes here? The slope. Now be careful, because it's y over x. So we might make this minus t and plus 3t. Would that give me a slope of negative 1/3? Now, what if somebody got wild and crazy? Because all the directions said were write parametric equations. What if somebody did this? Would those be parametric equations of the line? Yeah. How how many answers are there to this question? A lot. The only thing you have to make sure is this has to be a point on the line. And since I gave you two of them, let's just use one of those. And this has to give you a slope of -1/3. So as long as those are in the ratio, you're golden. All right, let's try another one, since that was a little bit different for us. Let's try another one. Let's suppose your job is to write the parametric equations. -2,1 and 5,3. Alright, so you're going to write the parametric equations of the line through those 2 points.
Find slope.
Alright, so step 1, we need that slope for sure. So, I got +2/7. Did I do that right? Alright, so you're ready to go. What are you going to put here? 5,3. This will be 2 and this will be 7. That's the biggest mistake. You got to remember it's y over x. You okay with that? Alright, that's enough for now. Let's see what we're going to do for homework tonight. You have in the thing I just gave you, Prequest 6-1 to 6-3. Let's give this your best shot. Answers are on the back of it. Let's see how many of these you can do. Some of them we talked about today. Some of them we'll have to talk about again tomorrow, but that's okay, we'll get it done. So you're doing Prequest. Alright, and I need to double check my attendance. So who showed up? Did John ever show up? Jamie? Sarah showed up.